Okay, guys, Chapter 3, Parallel and Perpendicular Lines. Before we start, I want to do a quick review of a couple of concepts. Vertical angles. Remember, vertical angles are these paired angles that are opposite of each other. So 2 and 4 and 1 and 3 are vertical angles to each other. And let's look at our 4 options. And unfortunately, I don't think 1 and 3 is in there, right? So it's only 2 and 4, angle 2 and angle 4. So option B is our correct answer. Next one, the measure of angle 7 is 68 degrees, and angle 7 and 8 form a linear pair. What is the measure of angle 8? So a linear pair, a linear pair suggests that it's a straight line. A straight line is 180 degrees. So if we already have angle 7, this is a little bit less, but it's about, let's say it's 68 degrees. All we need to do is to use 180 minus 68. We should have this angle, which would be 112 degrees. Number 3, which of the following is the solution of the equation 5x plus 9 equals 6x minus 1? So this is a quick algebra review. And there are 2 ways to explain this. If you hang around with me for a while, you're going to get used to the fact that Ms. Birch liked to try different ways of solving problems. And that's my quick and sneaky way of verifying that that I solved the problem correctly. Because if I can find 2 ways to solve a problem and arrive at the same answer, I know I got it right. Therefore, I don't need to go back and redo the problem in the same way. That's kind of boring for me. Okay, so one way that you are probably very familiar with is something called inverse operation. Inverse operation meaning the opposite operation. We only have 4 operations: plus, minus, multiply, and divide. So let's see which one we can use here. 5x plus 9 equals 6x minus 11. You know, what's really annoying is that we've got the variable terms on both sides. So if I can get rid of this 5x on the left-hand side by doing the opposite, I minus 5x. And because I do that on the left-hand side of the equation, I have to do that on the right-hand side of the equation. And that way I can cancel the 5x. I only have 9 left on the left-hand side. On the right-hand side, 6x minus 5x, I only have 1x left, and I bring down minus 11, right? And by the same token, I can do plus 11 on both sides. I still can maintain this equal sign here. And on the right-hand side, I have x. On the left-hand side, I now have 20. So that's my final answer there. That's one way to explain it. Another way that, a quick way to, it sort of skips a step, which some people don't like, but I like to take shortcuts. So let's see. If I want to group all the x terms together, here's the x term, here's the x term, and then all the numbers on the other side, what I really want to do is to get rid of this. But if I get rid of one term on one side, I have to do the opposite operation on the right-hand side, meaning I have to do minus 5x on the right-hand side. See that? That's how I cancel the 5x on the left-hand side. And by the same token, I want to get rid of negative 11 on the right-hand side because I want my x terms together. So I want to cancel that, and all I need to do is I need to add a positive 11 on the other side. Notice that? The 5x, I moved it to the other side. I changed the sign here. And then the negative 11, I moved it to the other side. I changed the sign in front of the 11. This method is called transposition. And now let's see what's left of it. I'm going to use my red ink. On the left-hand side, I have plus 11 plus 9. That gives me 20. On the right-hand side, I have 6x 6x minus 5x, I only have 1x left. Wow, look how nice that is. These are exactly the same. So I know that I found my correct answer. My apologies for my chicken scratch. I have to do this on an iPad, so it's not a lot of space to write. Okay, now let's do some serious geometry. Let's look at lines. I suggest that you pause the video at the moment, copy down these definitions, and then let's come back and have a discussion about it, okay? So let's see. Parallel lines. Parallel lines are coplanar lines. Remember those? Coplanar meaning they're on the same plane. And a plane is just like a sheet of paper. It's very thin. You can almost never see it, but it's right there, like a sheet of paper. So parallel lines are coplanar lines, but they do not intersect. So they look something like this. Okay? Perpendicular lines, those are lines that intersect to form a right angle. So usually they come with a little thing that looks a lot nicer than my chicken scratch, but a little square like that. That indicates it's a right angle. It's 90 degrees. Right angles are 90 degrees. Skew lines, they're a little bit complicated. Skew lines are non-coplanar lines, not parallel, and do not intersect with each other. What do we mean by that? I flunked my art class when I was 7 because I couldn't draw this box. And now I'm a lot older than 7 years old. I still cannot draw this. Imagine this is a Rubik's Cube. And think about this line. If I take this line in the front and then I take this line in the back, notice that they're not on the same plane, they're not parallel, and they obviously do not intersect with each other. So these two lines are skew lines. I like to call them triple note lines, not on the same plane, not parallel, and not intersect. Triple note lines are skew lines. Parallel planes are self-explanatory, two planes that do not intersect. And the line perpendicular to a plane. So now if I want you to imagine that you hold put a sheet of paper on the table, then you hold a pencil, the pencil goes straight down towards the paper, and when the pencil touches the paper at exactly just one tiny spot, one tiny point, that's when straight down, that's when the pencil is perpendicular to the plane, and there has to be a right angle between the pencil and the sheet of paper. And doesn't matter how many lines you draw on that sheet of paper, those lines are always perpendicular to your pencil. All the lines on that sheet of paper form a 90-degree right angle with a pencil that you hold up on top. So that's a line, that's what we call a perpendicular to a plane. So let's see, if you feel comfortable with those definitions, we can proceed. If not, go back and draw a couple of lines. And we don't have a lot of practices in this video. As you can tell, geometry, it's a lot of seeing, a lot of doing, and hopefully you get a good feel about it. The good thing about it is it's actually, there's very little calculations of it. And in class, we can talk a little bit about the history of geometry, and you will know why it is the way it is. It's a fascinating part of mathematics. So let's look at this example. Identify which are parallel, which are perpendicular lines, and which lines are neither parallel nor perpendicular. So line M is right here, and line N. N and M are parallel, because look at that. Doesn't matter how far away you extend the line. Okay, I'm doing a terrible job here. It doesn't matter how far you extend those lines. You can go all the way to China. They are not intersect. They're not going to intersect with each other. So they're parallel. And we use that ugly symbol that I just drew to describe what parallel means in math. Line P and Q, change the color, it's the blue. two lines. Notice that they obviously are not parallel because they intersect right here. And also notice this angle is clearly larger than this right angle on top. So therefore it's not perpendicular either. So we say that they are neither parallel nor perpendicular. Again, my apologies for my chicken scratch. And then finally, N and P. N is right here, P is right there. They intersect right here and they intersect at the right angle. So they are perpendicular to each other. Okay? This one, skew lines. Determine whether the lines are skew. F and H, what do you think? F is right here and H is here. What do they have here? They intersect. I said skew lines are the complicated triple note lines. They're not on the same plane, and this satisfies that condition. They do not intersect. Oops, that's where they intersect. So, therefore, F and H are not skewed. Sorry, even I have to rewrite this, are not skew because they intersect. And then F and G, obviously, they are skew. They are skew because they meet the triple null criteria. They're not on the same plane. Because F is intersecting with H here, G looks like it's behind H. So it's not intersecting with F either. And what's the third criteria? They don't parallel. So that's the answer for that. Here are some checkpoint questions that you should go through quickly. I will most likely use these as do-nows tomorrow in school. Okay. Example 3. Identify relationships in space. Okay. Name a plane that appears to parallel to plane B. You've got 3 planes here. You've got plane B, you've got plane C, and then you've got plane D. And remember, parallel planes are those that never intersect. And clearly, B and D intersects here. So B and D don't parallel. C and D intersects here. And these 2 planes, if you imagine the bunk bed going against the wall, and the 2 bunk beds are parallel to each other, but they are actually perpendicular to the wall that they are standing against. So in this case, C, plane C, appears parallel to plane B, right? And obviously plane line L, which is this line here, it gave it away. There's a 90-degree angle. Line L appears to be perpendicular to plane B as well as plane C. And here is another checkpoint that I'm going to walk you through this. Think of each segment in the diagram as part of a line. Name a line that's skewed to VW. VW is right here on the side in red. And if we want to find a line that's skewed to it, it cannot be on the same plane. So let's see. I can pick this line here. They're not on the same plane, are they? Are they on the same plane? You probably can't see it quite yet. But notice that there is an invisible plane. Think about this as a square cake. And if you're cutting it diagonally, now you're putting QT and VW on the same plane of QTWV, right? So that's a little tricky with this one. So it cannot be QT, all right? So let's try another one. We have to go to another plane, what about QR or TS? Look at these two. They are on different planes. VW is in the back, and QR and TS is on the left-hand side. They do not intersect, and they do not parallel with VW. So either QR or TS would be a good answer. There are some other possible answers. See if you can come up with these answers by yourself, and altogether you should be able to find 4 lines. We have identified 2 lines that are skew lines to VW. Altogether there should be about 4 answers that works. Number 5, name a plane that appears parallel to VWX. VWX is this one here. Let me use black. VWX is this plane. So that's, if you imagine a box, it's fairly easy to find a parallel plane to VWX. Now name a line that's perpendicular to VWX. Name a line that's perpendicular. Now if think about which plane do you want to pick? If you want to pick RVWS, that plane in the back, I would say this line, VW, let me do red, VW is 90 degrees. XW is also perpendicular to that plane. And QR right here is perpendicular, and TS is also perpendicular to that plane. So I picked a plane that's in the back that's harder to see. You can also say that VW is on the plane of UVWX, and then there are 4 other additional lines that's perpendicular to that from that perspective. Okay, that's it for 3.1. It's again, geometry is all about seeing and feeling. So feel free to go back to see more, or try to see more from a different angle, from a different perspective, and feel more. It's much less about calculation, and we're going to try to do most of the reviews of algebraic calculations in class, so that you don't need to be overwhelmed by homework at home. Okay, thank you guys. I'll see you in class.